Well, welcome everybody to episode 5 of Bathica Banter. And I cannot be more excited about today's guest. Uh, he is the owner operator of Zook Electrical LLC. He is a photovoltaic solar expert, and that is my good friend, Mr. Ira Zook. Ira, say hello to everybody.
Hi, everyone.
Well, Ira, first of all, welcome to Bathica Banter, and thank you so much for participating in our show here.
Yeah,
Um,
thanks
I,
for
I,
having
I,
me.
I I want to start at the start, Ira, and what I mean by that is I'd love to hear your journey. What got you to the point in your career that you are now, and how did you get into solar as a career? Please.
Okay. Yeah, that's actually a question that comes up a lot. So the I started installing like the small off-grid systems in the Amish community back in the uh, back in like 2007, I believe it was. So that's kind of where I got started, and then it progressed to, and then in 2009, 2010, Pennsylvania was actually doing some grants for systems.
Yeah.
So then it kind of took off to, or the grid tie part of it kind of took off. Back then, the systems were probably, well, panels were probably 4 times more expensive than they are today.
Yeah.
Um, so it was it was a much more difficult financial case than it is today.
Sure.
Um, so the grants are kind of what at the time kind of what helped speed things up, I guess.
Hmm.
Um, and then for a while, I was working for a large solar contractor um, doing grid tie or doing commercial and utility scale projects. Eventually, I worked for a few or for electrical contractor for a while. And I was also going to college part time.
Yeah.
So and and then before I went back on, I went on my own. I was working for a company, a solar contractor, a little north of here. So then went back on my own, and it's kind of where I'm today.
Oh, very cool. Yeah, so a lot of different aspects and avenues and
Yep.
ways to go to finally get you, which I think is typical in most people's career, especially in
Yeah.
the trades for sure. Yeah.
Yeah.
So, uh, Ira, when you are sizing a photovoltaic solar system for a residential home, what criteria and data are you basing it upon?
So if it's a roof mounted system, there's usually it's the most common limiting factor in terms of size is available roof space.
Sure.
So the average two-story house does not have sufficient roof space available to put enough panels up there, at least not in this area, um,
Right.
to put enough panels up there to actually cover their bill. So that the other limiting factor would then be, what's the maximum that they want to do? Usually people want to cover the bill, cover their usage as a minimum. So that would be the other limiting factor is that you at some utility companies historically, or some utility companies will only allow you to go up to say 105%, or there's some that actually will only allow 100%. um, these days it's not. I think some of those rules may still be on the books, but they're not really enforced anymore with some utility companies. um, so it's, but yeah, basically you start with what the usage is, and then you try to achieve that if you can.
Sure. And the usage, the existing usage is based upon utility bills that
Exactly.
yeah,
Yeah,
yeah.
it's the previous 12-month usage. So
Yeah.
size based on the annual usage here.
Yeah, I'm sure most people's utility bills is like mine. You get this what looks like a book of
Yeah,
information. You never
yeah,
really quite know what the heck it means, but
right.
that's critical for your
Yeah,
sizing
yeah.
criteria for sure.
Most utility companies here actually have a total annual a sum of the annual usage somewhere on the bill for residential customers.
Yeah.
For commercial and industrial customer, for some reason, that's not the case. So you usually have to actually request it if you want a hard number. And then there's some co-ops and municipal utility companies here that um, don't really. I like there's one municipal utility company here in Pennsylvania um, that the bill shows up on a postcard. So
Well, how nice of them.
yeah, yeah. So I mean, it's a postcard specifically for that, and the data is or the text. It's actually printed on there, but it's weird. It must be like a machine or something from probably the '60s or '70s that was just never upgraded. So I mean, they probably save a little bit of money on postage. I
Yeah,
don't know, but
yeah. Hopefully, they're passing that on to the end user, but
right,
probably not, right? Well, Ira, look, you oversized that was the perfect segue into my next
right,
question because you talked about sizing and oversizing, and that in some cases utility companies will limit you as to how much you can oversize. Now, in our particular case, in Patricia and I's home, you oversized by approximately 16%, which I love, and I'll
yeah.
tell you why I love it after you answer. But why was that done? Why did you go 16% bigger than what we would have required, if you will?
So I'll usually target somewhere around 105%, maybe 110%, if I can. But a lot of times it comes down to rounding, right? So
Okay.
if you're on a ground mount system, if you're doing um, multiples of four, and let's say 105% would have been four less panels.
Oh,
Usually I'll just round it up. Um, to hit the 110 or 115 or sometimes even 120%. The other consideration is sometimes when you're matching up panels with inverters, since these are string inverters on ground mounted applications, um, sometimes when you're doing matching up the panels with the inverters, sometimes you're one of the limitations is voltage, like how high the voltage can be per circuit going to the inverter. So if you're wanting, let's say, two circuits of 10 panels or two circuits of 12 panels, then sometimes it's a matter of if you have multiple inverters, you'll just do 2 circuits of 10 panels for all of the inverters or something like that. So
gotcha. So it really is kind of a factor in the production capability of the panel and the inverter, just like you say, just kind of rounding things out to
right,
a number either above or below. Yeah, the reason why I love it, that it's a little bit larger than we actually needed, was if we decide to put in a pool heater or
add
something like that,
yeah,
we have that extra production, which I'm very happy that you did that. So that's great. So look, Ira, you've mentioned a couple of times already ground mounting versus roof mount. Now ours is ground mounted, and that was I think chosen for a couple of reasons, but most of all, that's what I wanted. That's what
yeah,
Patricia and I
yeah,
wanted. We didn't want anything on the roof. I
right,
used to back in New York and New Jersey. I used to do thermal solar, which is production of hot water,
right,
and I I learned a lot about roofing as a
yeah,
result of that,
yeah,
more than I ever wanted to know, quite
right,
frankly. And I know with roofing, oftentimes it's best to change the roof as the panels are being applied so that the
Right.
age of the roof matches the aging of the panel, if that makes
Yeah.
sense. But this is a long way to get to my question. My question to you is this: is there a preference on your part as far as ground mounting over roof mount?
Um, y- yes, but primarily it comes from so ground mount systems are generally easier to work on and install because you and can when compared with a two-story house roof,
Sure.
because generally everything's accessible and you're not climbing up and down ladders all day, and you're not having to basically get everything up on a two-story roof. So from that perspective, yes, they're much easier. Unfortunately, they also do cost a little bit more because of all of the steel that goes into the steel and fittings that goes into building the structure.
Right.
However, some of that cost is recouped in labor savings because a ground mount installation generally will require less labor to install, even with having to build the structure,
Gotcha.
than a roof mount system will. The exception would be probably your case where it's a single story, it's a single story roof and it's a relatively low slope, low pitch. So
Yeah. Yeah. I just, I see most of our neighbors have gone ground mounted like we did. Well,
yeah,
first of all, we had the property, right? You
right,
know our
yeah,
property. We have 4 acres. I call it golf course quality. It's level.
yeah, yeah,
Uh,
really,
we were able to position it off to the side, so
right.
it's not directly in front of the house. But I do see in the neighborhood other people going roof mounted, and there's also I don't like the aesthetic of the roof mount. I don't know.
Yeah, in some cases it kind of blends in.
Yeah,
Some cases
yeah,
it kind of blends in, but then other times it really does kind of stick out and doesn't look all that great aesthetically. Uh, what I've been finding is I would say probably half or more of the roof mounted systems that we're seeing these days are installed by larger companies that are offering either some type of a lease agreement or some type of financing or something like that. There's some of those the property owner doesn't actually own that system.
yeah, yeah.
And they're basically buying the electricity from a the electricity that the system generates from a third party, um, and most of those deals really are not that great. Um, Unfortunately, there's been a number of them that where basically the companies went out of business, and some of the customers have roof leaks.
Yeah, yeah,
So
yeah.
so
That sounds like a disaster for
yeah,
sure. Yeah.
yes,
Well, look, Ira, using our home here
yep,
as the example, so the installed cost for a 23.04 kW AC system was $64,000.
yep,
So my question to you is what tax benefits, what rebates, what financing opportunities exist? Not everybody could take 64K out of their pocket.
right.
So where are the tax benefits nowadays? Rebates, please help us understand how some of that may be recouped.
Yeah. So in Pennsylvania, unfortunately, there's not a lot of significant incentives, I should say. Um, Pretty much the only one is the renewable energy credits. I keep calling them carbon credits. I know
Yeah.
it's not the correct term,
Yeah.
um, but basically those are these days are worth 30 to $40 per megawatt hour. That's the system. So that's a performance based incentive, but that's pretty much the only thing that's available from the state. Um, on the federal side of things, there is the 30% federal tax credit, which helps some people out more than others. Like if you're self-employed, that's a huge advantage to some people.
Sure.
So that's something that kind of depends on your uh, your tax liability situation. Um, on the financing side of things, uh, there's I per as a company, as a small business, I don't really offer any financing other than like you can pay for these systems with a credit card if you really want to.
Sure. Yeah.
But that's not really considered financing.
Right.
Um, and the reason I've kind of taken that position is because 99% of the time, my recommendation is if you do need to finance it, work with your bank
Yeah.
and get a home equity loan, or I think of some I think
A
it's
line of credit or something. Yeah.
second mortgage or something.
Right.
Um, and the reason I say that is because you then have control over, how quickly you pay it back. Generally, there's no prepayment penalties or anything, and you're in control of how much interest you end up paying over the term of the loan. Additionally, those are usually 5-10 year loans, which is about the 10-year mark. Even if it's financed, should be somewhere around the break even period.
Right.
um, the reason I don't recommend going with companies that offer financing in house, especially these days, is because that's pretty much where all of the shady stuff happens that goes
Yeah.
on with solar. Um, the financing, the leasing, the power purchase. Some of the power purchase agreements are okay, but you got to remember you're signing a 25-year contract. The
Yeah.
problem with the financing is that most of these are structured as 20-year loans.
Yeah.
Um, and with today's interest rates, if you break down the numbers, a $68,000 system, if you were to finance that using that in-house financing, you, you most likely would end up paying 3 times that amount
Yeah.
by the time
Right.
you have paid for it. So if I had checked into some of the financing, into offering some of it, and basically the dealer fee that I would need to pay or include in the cost. Basically, I have to include it in the cost somewhere. But
Yeah.
the dealer fee, just to be able to offer, just be able to have that I have to pay if a customer finances this system, is around 40% these days.
Ooh. Ooh.
Yeah.
Yeah.
So that by itself is now that helps buy down the interest rate. These days, you could probably get it down to 2% or something like that.
Mm.
Um, but you're paying up front. That gets included in the cost somewhere,
Yeah.
and at that point, you're actually most cases you're probably better off not doing it. You
Yeah.
know, so.
Yeah. Well, a couple of things jumped out at me, Ira, in your answer, and the first of all is the tax credit.
Yep.
Um, when we talked to our accountant last year
Right.
for our 2022 taxes, we told him of our intent
Right.
to do this project with you, and his advice was, Jerry and Patricia, if you're going to do it while you're still working, so
Yes.
that you can
Yes.
take full advantage,
Right.
because he knows our age. He knows that, we don't intend to retire anytime soon, but we are getting to the age where we can see
Yep.
the retirement in the future.
Yep.
So he pointed that out so that we can take full advantage of that 30% federal tax credit. So yeah, I'm looking forward to
Yeah.
that.
Yeah, that's actually a really good point because it's a federal tax credit. So if you
Yeah,
have no federal tax liability, then
kind of
you,
useless.
yeah, it really is. You can't take advantage of it. So
Yeah.
unfortunately,
Yeah, so good advice on his part for sure. Another thing, talking about the financing side of it, it's interesting. Two prior guests to you on our program here, Ira, are involved in HVAC equipment financing.
hmm
Um, And that has gotten to a very high level of sophistication
Yeah.
because of what you described,
Right.
quite frankly, the shenanigans
Yep.
that took place early on in the
Yep.
early versions of financing, which it sounds like solar is a little behind where HVAC is,
Okay.
as far
Yeah.
as sophistication and weeding out some of that
Yeah.
shenanigan, as
Yeah.
I call it. But you mentioned credit card over loan. I mean, come on, credit cards are, I always say the interest rates are kind of like dealing with Tony Soprano,
Yep.
right?
Yep.
You
No,
know,
that obviously would not be a long-term solution.
no,
It's not financing. That's
right,
basically it. It would be something that could be used for a short term, if
right,
say you're in the process of selling some real estate somewhere or something like that.
exactly. Yeah,
Um,
just to hold you
and you're
over.
trying to all do a lot of things in 1 year or something. And then I think most commonly, people want to use them for the the miles or the cash back or something. I think
Oh, I
that's
didn't
what
think of
happens.
that. Yeah,
Yeah.
yeah.
So
Wow, I could have took another trip around the world based
yeah.
upon. Something that came to mind, going back to
Hmm.
an earlier question about sizing the system larger than our actual need, in our case, 16%. You were mentioned that some utilities are actually restricting just how much further you can go. I do
Yeah.
so much business in Canada, Ira. I know that in Canada, some utilities, as you mentioned, are not allowing you to even go to 100%
Yeah. Yeah.
of capacity. I find the Canadian market for solar quite a bit different than at least what we experienced with you here in Pennsylvania, and just the general Pennsylvania market for solar. There are some very interesting federal loan capabilities up in Canada for the
Okay.
homeowner, where they can literally finance it. I don't hold me to this, Canadian audience, but I believe literally interest free for like 40 years. Uh,
Wow.
yeah, some really
Wow.
interesting federal loan opportunities, as I understand it.
Yeah.
So that is an advantage that they have, but I think the disadvantage is the utility companies up there have been quite restrictive, and I'll even get into more detail about that in an upcoming question. But what I want to get to now, Ira, if you would, is warranties. What are the warranties on the panels? What are the warranties on the inverters, and where are these things coming from? Where are they manufactured?
So for your system, um, the inverters, the company is based in Germany, and as I recall, I believe we actually did find somewhere on the label that it did say that it was manufactured in Germany, I
Right,
believe.
right.
So because I was not certain as to where they were actually manufactured, if they had the manufacturing in house, but for those at least, it appears as if they still do.
Right.
Um, so the standard warranty on those inverters is 10 years.
Hmm.
And they've actually been really good. I've only ever replaced a few of them. And um, and whenever that does, if that ever does happen, it's with those inverters. If I didn't have to reconnect some of the monitoring or do some of the paperwork, if
Right.
there were no paperwork, the physical replacement of the unit itself takes all of about 10 minutes.
Oh, okay. Yeah,
um,
nice.
so, so that part's really easy. You can extend, I think within the first year or so, you can pay for the extended warranty from the manufacturer.
Hmm.
And I believe you can, I believe it's in 5 year increments. So you could extend it to, I believe, a maximum of 20 years. The cost to do so is practically the cost of a new unit,
Oh,
of a
okay.
new inverter. So at least to today's. So I actually had one customer one time that I basically did the math and said, oh, a new unit is actually $50 cheaper or something like that than paying for the extended warranty. So why don't I just buy a spare unit and
Oh, yeah.
I guess leave it in the basement or something.
Yeah, yeah.
Um, so that's what they did, because the reality is, 10 years from now, it's going to be a different unit. So the replacement won't quite be a drop in. However, you know, take that as you may.
Yeah.
Some manufacturer warrant obviously manufacturer warranties are only as good as the company that provides the product and warranty. Um, they have been around for years. I'm not even sure when they started, but I would be surprised to see them go anywhere anytime soon, because
Yeah.
they're really one of the leaders in the industry. Um, the panels, I believe those came from, was it South
Cor-
Korea, I believe it
Yeah,
was.
Korea. Yeah.
Yeah,
That's my memory of it. Yeah.
yeah. Um, and it, those have a those their warranties kind of weird. There's I believe a 30-year performance guarantee,
Okay.
which is basically saying, um, 30 years from now, it's still guaranteed to be producing, I believe it's 80% of its original rated power.
Okay.
Um, but what makes it confusing is they have a 12-year workmanship warranty.
Hmm.
Um, However, a lot of things overlap because
Yeah.
generally, if there's an issue with the panel, it affects performance.
Sure.
So, what I interpret that as, if say the machine that manufactures the robots that manufacture these things messed up, and they didn't put sealant in the one area of the panel, right, as it's assembling it. Um, and then over time, moisture gets into that area and causes, premature degradation. That would be something that would be obvious in the monitoring, and that would be something that would fall back onto a product warranty,
Right.
or workmanship warranty, basically. And in my experience, workmanship warranties and product warranties, if there's going to be a quality issue, or an issue that was due to, the product not being assembled correctly or something, generally those problems are obvious or reveal themselves within the first few years.
Yeah.
So if you make it past 5 years, with no, which generally they do, I think I've only had one panel ever
Hmm.
that, it was like an out of the box failure.
Right. Right.
um, but basically, if you make it past 5 years and there's no, um, there's no workmanship issues, usually they'll go for the next 20 years or so,
Yeah. You're
and
going to be good.
there's really no issues. The most common cause for replacing panels in this area, believe it or not, is, bullets. so,
Oh
so
my.
yeah, I don't know, target practicing or something. I don't know what's going on some of these places, and it's usually like in the country, so it's like in the middle of nowhere. So,
Right.
I'm assuming,
Rural Pennsylvania. Yeah. Yeah.
yeah. So, and then
Yeah.
I have replaced a few because of fireworks, which,
We'll
so
talk about that.
yeah.
Yeah. Yeah, well, that's a nice segue into yeah. We experienced that. Our neighbor shot off some aerial fireworks on the 4th of July, and one landed on one of the panels. I don't even think you had commissioned the system yet.
No, it wasn't fully commissioned yet.
Yeah, and
Yeah,
it literally burnt because it landed and then stayed on the panel.
right.
It didn't just
Yep.
simply roll off or bounce off, and it caused what looked like could have been a problem. So yeah,
Right.
Hugh just thought it was best just to replace it, and Yeah, and the neighbor was great about it, so that's all
Yeah.
cool. But yeah, it's things you don't think about. Certainly,
Right.
I didn't think about such a thing, right?
Yeah.
Absolutely. A couple of things I want to touch on from your answer, and you mentioned, okay, it sounds like the inverter and the panels, you're definitely covered for 10 years. The panels
Yeah.
may go beyond that. The inverters maybe a couple of years beyond that, but certainly 10 years sounds solid that you're good. But backwards compatibility could possibly be an issue, and I know
Yeah.
that's in my business.
Yeah.
With HVAC systems,
Right.
people may want an evaporator to match up with now a 3, 4, 5-year-old outdoor unit, and I can't guarantee that backward compatibility.
Right.
So your thought of having a spare inverter, in our case, we have a spare panel
Yeah.
because of the fireworks situation. Brilliant idea. Again, if you have a place to store them, the panels are big.
Yeah. Yeah.
And they're awkward and they're large.
Right.
But if you have a place to put it, great idea. It
Yeah.
just takes any worry out of that in the future for sure. Another thing I wanted to touch on, and I mentioned this to you when we were going through this process with you, when our insurance agent, our homeowner insurance agent, found that we were having solar installed, he said, "Well, you know that there is a policy for that." And he's a great guy, and he was very upfront
Right.
with us. He felt obligated to tell us that such a policy existed to cover it, but he also said, "Jerry, Patricia, to be honest with you, I never sell these things.
Yeah.
It really doesn't make any sense."
Yeah.
And when we described it to you, if my memory is correct, you kind of said, "Look, if anything that would be covered by that policy actually happened to the panel, it's probably the apocalypse, and
Yeah.
there's bigger issues, right?"
So I think, if I remember, I think that policy was probably so in some states. In some states, that policy is actually required by the legislation,
Oh,
and it's because of it's likely because of lobbying from the utility companies.
ah,
So basically, what that policy does is in the unlikely event that, say, an inverter malfunctions during a power outage and it feeds energy into the utility grid,
mm,
and there's a lineman working downstream somewhere
yeah,
and they get injured because your system malfunctioned and caused an energized circuit.
right.
Um, that's my limited understanding as to what that policy does. The reality is that that would be a scenario that is so unlikely
Yeah,
that because even if something like that did happen, that even means that the line crew was not following their own safety policies.
right.
So the odds of something on of a small residential system like yours having any impact whatsoever on the utility grid as a whole during a fault event or something
Yeah,
is so unlikely. Now, if it's a 5 megawatt system that's covering where panels are covering 20 or 30 acres of area, that's a different story.
yeah, that's a farm, a
Yeah.
solar farm.
Yes.
Yeah, something of that nature. Yeah. Another thing, if again, if my memory is correct, and often it's not, I seem to remember the insurance policy also covered something as silly as if like a panel came loose in a windstorm and hit somebody or something like
I
that.
believe I bet so some of those are usually those are kind of like two separate policies where
Yeah.
the one that the guy said basically never sells, um
Yeah.
that is a liability type of policy.
Right.
um the other one which is usually part of your homeowner's insurance policy, and is sometimes even covered just with the standard policy. It
Mm,
really depends on the insurance company, um, and those will generally cover the replacement of a panel or the replacement of the whole structure and array
right.
if needed. Um, but I believe I forget what the situation was there. You might want to check with your insurance company again.
Mm,
But I think they may have actually said that there was like a minor modification or something.
mm,
Like the policy we were talking about earlier was something that is kind of unrelated to the actual replacement products, I think, or
right.
replacing of the
Yeah.
equipment.
Yeah.
Um, I did have one years ago that actually the most of the actually all of the panels needed to be replaced because some trees came down on it.
Sure.
So basically, we put the structure along the back end of the yard or whatever, and there's a row of trees probably 20 feet behind it.
Yeah.
um, and a couple years later, after it was installed, there was a pretty significant event. Like there were people that lost the roofs of their houses and stuff
Yeah.
during that
Yeah.
event in
Yeah.
that area. Basically, it took down that row of trees,
Yeah.
and but these were huge trees.
Sure.
So
Yeah, I could definitely see how that. And here in what is the Susquehanna Valley of Pennsylvania, we have wind,
yeah, yeah,
which I've never experienced anything like it. It doesn't ever just rain. It's always rain with this really intense wind. But yeah, so but again, just to give you props, Ira, you over-engineered the ground arrays of these things. I documented that, as you remember, during
right.
the actual install process, and put that on LinkedIn, and people can go back and review those videos and those links. That yeah, those things ain't going nowhere. To
No,
say that again, it would be the apocalypse,
yeah, yeah,
and we would have bigger issues.
yeah,
Hey, look, Ira, I want to get to um, the really good news about our system here, and let me share this with the audience. So, prior to the installation, our electric bill for cooling averaged about $350 per billing cycle, and for heating, Ira, it ran as high as $750 for the
yeah,
billing cycle. Now, just to give our audience a complete understanding, we are a totally electric home. And actually,
right,
this studio is in a separate structure, but all on the same electrical meter, or the electrical grid,
yeah,
if you will. Uh, so those exorbitant numbers, because I'm sure people are going, what? That's
yeah,
crazy. Those numbers are based on the local utility rates here in central Pennsylvania, essentially doubling each year for the 3 years since we've owned the home. I could have a whole nother show dedicated to that subject, and I don't. We'll address that some other time. But here's the good news. Since the solar install, our electrical bill is now $16.
yeah.
$16, and that's every
Those are the
billing
fixed.
cycle since the install.
Yeah, and those are
So
the fixed costs.
yeah,
And unfortunately, not to and not not to so basically the reason that has happened, and um I'm I would be very surprised if the next bill will be the same. And the reason that that happens is we here in Pennsylvania, with the in if you're in the public, and if your electricity is coming from or supplied by a public utility, one of the public utilities, and not by a co-op or a municipal utility company. Basically, we have it's essentially an annual net meter, one-to-one net metering,
okay.
and um, what happens is, and that's why the systems are sized based on the annual usage.
Right.
So what happens is if the majority of your usage is in the wintertime, what will happen is in the summertime, the system will be overproducing. It will be producing in excess
Right.
of what you're consuming by a significant amount. And what happens with that excess is gets um, it gets recorded as what they call banked energy.
Hmm.
Um, and it's basically they're tracking it and it's banked energy that can then be used at a future date. It can be used in the future, like say the wintertime.
Right.
Um, the reason why some customers, and you're probably going to be one of them. I'd have to check the historical usage, but I'm pretty sure you're probably out of banked energy at this point. Um, and probably the next bill might be a little higher.
Yeah.
However, the reason that would have happened is because, or the reason that will likely happen is because your system was only operating for what, like half of, not even half of the year last year, right?
Right. Right.
So some of the most productive months, your system was not operating yet. So it
Exactly.
didn't have the opportunity to
To
make
bank.
enough energy to store in the bank for the entire winter. It has
Gotcha.
done, it has been able to so far, but it probably won't be able to however, next year then, um,
Yeah.
it'll be fine. So
Yeah.
that is something that comes up quite frequently where like we'll install a system in November or December, and the first winter the customers are like, what the heck, it's barely doing anything. In your
Yeah.
case, you had significantly more time than that, so I forget when we turned it on. Was it like maybe August or something like that,
August, I
mid
think.
July
Yeah.
or August?
Early August, I think, is when we really went
Yeah,
100% commissioned. Yeah.
yeah. So
Yeah, well, that's interesting. I'm getting a little ahead of myself in my question, so don't answer what I'm about to comment on.
okay,
But I do expect the next build to be a little bit higher, but for some other reasons that I will speak about when in another question. But
okay,
yeah, you know, but the bottom line is, Ira, 700, the last billing cycle 1 year ago,
yep,
$750.
yep.
This year, $16.
Yep.
My
it's
friend,
doing it's doing what
that
it's supposed to.
it's doing what it's supposed to,
Yeah.
and exactly what you told us it would
Yeah.
do. So
Yeah.
Patricia and I thank you so much for that. Hey, look, so the initial proposal for our system, you stated a return on investment at 312.72% with a 7.7-year payback. Now, that was based upon an average electrical bill of $62. As I mentioned earlier, our actual bill has been $16. So I do think our payback will probably be a little bit shorter than you anticipated. But again, that may be adjusted by what you just described in your last answer to me, and that's fine. But here's my question to you, Ira. When you're in front of a potential customer like Patricia and I, what are you finding the customers' biggest concerns are? What are their questions? What are their concerns about the possibility of having a system put in?
There's there's usually um I usually the biggest one is the the cost of the energy. So
Yeah,
a lot of people have kind of come to realize that there's not really there's not really a cap, or um the, there's not really anything other than basic supply and demand
right,
that is keeping the price, the price of the energy where it's at.
right,
So here, the cost of energy is closely tied to natural gas because of, as it probably is most places in this geographic area. Basically, because it's closely tied to natural gas, as soon as the cost of natural gas goes up, the cost of electricity goes up, and that's what had happened, where it basically went up significantly, and then demand also went up at the same time, um, and things weren't looking so great for a while there.
Right.
um, so basically, those a lot of those calculations are done with software. And it's basically a piece of software that you enter some basic parameters, and it runs all of the numbers. Um, it is actually based on it is based on a number of factors, but it would be based on the cost of the energy.
Sure.
It would be based on the cost of the energy, or basically it's based on the per kilowatt hour cost that it has the ability to offset. So if the bill, so if you use, you know, if you use 20,000 kilowatt hours annually, but it's going to generate. I'm just throwing random numbers out.
Sure.
Um, but it's going to generate 23. Then what it's actually doing is only factoring in the 20,000 kilowatt hours that it will actually offset,
Right.
because the the excess. So every spring there's 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 basically an event where they'll zero the banked energy, and I have to check what actually happens with in some utility companies. They automatically send you a check, and others you actually have to first make sure that you fill out like some of the tax paperwork,
Sure.
just in case it's more than $600 worth of energy,
Right.
um, before they'll even offer to like they're basically if in April or May you still have an excess of banked energy, they'll actually zero it, and there's kind of a black hole of what happens with that energy.
Yeah.
Um, there's some where there's some utilities where they'll just automatically send you a check, and others I think they're just kind of keeping it or something. So
Yeah. Yeah. Interesting. Well, Ira, uh, using Patricia and I as the example, I will share with our audience the actual proposals that you work for us.
right,
I always say when I'm in front of a group of our installers of HVAC, um, and they're trying to sell a heat pump system to a
right,
customer that could be $10,000 or in excess of
yeah,
$10,000. I always say, you need to take advantage of programs of software programs that will calculate the actual
yes,
savings for the homeowner. Because as homeowners, and we're homeowners, right? Uh, we all want to see things in black and white.
yeah,
I'm not in this case. I wasn't going to make a $64,000 payment
yeah,
without you telling me exactly what the heck this thing was going to do
right,
for us. And that's exactly what this one. You actually come up with two proposals. One is based on payback, return on investment. The other one is really performance
yep,
specifications. But the one based upon payback and what have you, again, very, very descriptive, and actual numbers that have rung true, I'm happy to say.
yeah,
So I don't know if everybody does this. You're the only solar contractor that we even talked to. We felt so comfortable with you, but yeah, you. I think how you handle it is actually absolutely perfect, and obviously very professional. Is to give people in black and white something that they can
yeah.
review after
Thank you.
you're at the dinner table with them, and
Right.
yeah, just beautiful. Well, Ira, one other thing you mentioned natural gas, and again, so many of our viewers are in Canada, and we do a lot of business in Alberta, where natural gas and oil comes from. Quite
Hmm.
frankly, Yeah. So heat pump technology up there. Uh, they go to Ira, just to educate you a little bit, if I may, to dual fuel systems, right? Where they
Okay.
take
Yeah.
an existing gas fired furnace or all fired furnace, they put an A coil on top of it. They use my heat pump as the outdoor unit,
Right.
and then they got the best of both worlds.
Yep.
So
Yep.
yeah, it's a beautiful thing. Well, look, Ira, I recently attended a global conference in China
Right.
late last year
Hmm.
and visited our manufacturer there, who showed us and gave us some information on a solar based HVAC system that they're working on. That I actually had sent you some information on it. Um, if I understood it correctly, has the capability of storing energy without traditional batteries. And I'm probably not explaining it right, but go ahead. Do you,
So um it has the capability of storing energy. However, you have to add batteries.
oh, okay,
Um,
okay,
so what it's really marketing, and basically what they're really marketing it as. So it it is a it is something that would make it is something that would make sense in warmer climates,
gotcha.
where the cooling demand closely aligns with the solar, um, with solar performance, right?
Gotcha.
Because then you don't have to add batteries or anything. It's basically, it has the ability to couple the DC output from the solar panels directly into the drive for the heat pump, basically. Um, so that is something that's actually fairly easy to do, but the condition there is that the cooling demand and the solar availability actually have to match up to some extent.
Sure.
They were then offering. Now they may actually do a package where they include some of the energy storage in it. It wasn't very descriptive
Right.
on that end,
Right.
um, but I suspect what they'll probably do is they'll probably just put like one or two batteries beside it. So then they no longer have to align. So then you can have you can have it charge the batteries during the day and cool at night or whatever. Um, in in ex, my experience with that, um, you're only taking one portion of, and I believe most of those were actually geared to, that had that capability, were actually being marketed to commercial and industrial customers. So I think most of those units that had that capability were three
Mm,
phase units,
mm,
um, which would make sense because the
sure.
load management or demand management is much more important in a commercial setting than, and it's pretty much irrelevant in a residential setting, at least in most areas. Um, However, for the residential customer, I personally, if you want to hook a couple panels up to that, up to the heat pump, it will make a difference. However, those same panels being connected to a grid tie solar system will offset significantly more than, especially that's assuming you have net metering availability, because be a they will always be able to use all of the energy that's available from the panels, where when you're having to match up the panels with the usage in real time, um, it may use 50% of it.
Right.
So maybe not the answer you were looking for,
No,
but
no, it is. It is very much the answer I was looking for. And your answer, though, does bring up a couple other issues, if you will. Batteries, again, when we were discussing just in the proposal stage or the design stage for the house here, I was very much against batteries.
Right.
And look, I may fall into hearing the urban legends and the horror stories about batteries causing fires and what have you. But it's just something that did not appeal to me, having
Right.
this bank of batteries actually inside the home. But it is the batteries that allow you. Well, clearly at night the panels are not producing anything.
Right.
The batteries would be able to store that when they are producing, and then offset what your needs during the evening hours. Correct? I mean, that's the whole
Yes.
concept of it. Yeah.
Yes, they do have the ability to do that. However, if you are in an area that has one-to-one net metering, um, there is no financial incentive to use batteries. Actually, it will cost you in conversion efficiency losses. Um, it will cost more to have batteries in a one-to-one net metering configuration. I'm saying one-to-one net metering where the energy that you send back to the utility
Right.
is worth the same price as the energy that you consume. And basically where there's no time of use or anything, any schemes like that, where basically it doesn't matter what time of day or what day of the month you're sending that energy back, you can then use that energy that you sent back at a later time. Um, because I only bring that up because there's a number of different schemes that utility companies, billing schemes that utility companies have. So time of use, like a certain time of the day, the energy costs more than it does at another time of the day, and they
Absolutely.
do that to incentivize um, load shedding during the expensive times.
Sure.
Um, there's other schemes where a lot of co-ops in some areas, instead of doing a one-to-one, they'll do there's some really horrible ones, but there's the better ones will say, okay, the energy that you send back to us is only worth 70 cents on 70% of what the energy that you consume from us. And basically they're doing that because um, that energy that you send back at that time may be traveling, it may be traveling 2 miles away, depending on the scenario. So there's some minor losses that it will encounter
Sure.
during that trip, that they're making sure it won't be anywhere near 30%, but um, because you could probably have it go clear across the state or something for that. However, they're
Right.
basically making sure that um, that it will never cost them anything. So, in those types of scenarios, there is a financial incentive to use batteries.
Right.
However, here, where we have a one-to-one net metering and it's basically an annual one-to-one, um, they're the only benefit to adding batteries to a system here is that it will allow you to have backup power during a power outage.
Ah.
That's the only incentive here. So, or the only
Well,
benefit, I should say.
Well, let's touch on that just for a second.
Yeah.
So, again, during the install process, I asked you that question.
Yeah.
When during a power outage, do we have electricity based upon the panels? And you said no, as you just described.
Right.
But you did say that there was the possibility of option of possibly hooking up one receptacle. I don't know if it had to be out at the array
It
or in the
usually
house,
is. Yeah. Yeah.
and it would possibly give us some
Yeah.
power.
Yeah, the inverters that I use there do have that ability. Um, it's the functionality is there, but I would basically just have to wire up a receptacle.
Right.
Usually use a small outdoor box or whatever.
Yeah.
Um, the reason I don't do that by default is because it usually leads to more questions than because what happens is basically there's an outlet out there in the middle of the yard that people want to plug an extension cord in all the time, but
Right.
it only works during a power outage if you flip the little switch. So like people are plugging the cord in, they're like, it's not working.
Right.
What's up with
Right.
this?
Right. Yeah.
um, But
Yeah.
yes, those inverters, I think they're like the only inverter that has that capability. It's up to 2,000 watts per inverter. Um, and obviously it only works during the daytime.
Right. Yeah.
So it would only be able to power things during the daytime. And to be able to get the full 2,000 watts out of that receptacle, you would need um, you would probably be able to get close to that on a cloudy day, but if it's
Right.
really overcast, you're not going to be able to get that amount of power out of it. So it can also, depending on what you're powering, like if it's a really overcast day, you could be trying to draw too much power off of it, and it will not start things with really high surge or
Ah,
inrush currents.
right.
So like it will not start a small air compressor. Like even
Okay.
like little pancake air compressors, it
Yeah,
will
yeah,
not
yeah.
start those. So
Interesting. Yeah, we didn't go for it just based upon everything you really just described. It was so limited
yep,
as to its practicality that,
right.
no big whoop. You know, another thing that your answer kind of brings up is when I told people and I told the world, as you know, I put it all over LinkedIn because we were so happy about meeting you and having you do the job, and obviously the ultimate performance of the system. We've been raving about it. But when you tell people that you've done this, when you tell people that you've gone solar, they assume that you're off the grid. Oh, so you're completely off the grid. That's fantastic. No, no, no. I always say, no, 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 we're not off the grid. Uh, to be 100% off the grid, I think is completely impractical, but it would also require the batteries, which I don't want.
It requires a substantial amount of batteries, and it is nearly impossible to do that on the conventional, on the average all electric home, because
Yeah.
all of your heating, the biggest problem being that all of your heating is going to be is the heating is going to be one of the largest loads, one of the largest energy consumers. And unfortunately, that only happens in the wintertime months when the solar production is the lowest.
Right.
So the only way that that would work is if you have some type of, and virtually all off-grid systems have either a diesel or propane generator or something like that tied to it.
Right.
Um, I usually tell people it's a lifestyle. It's not. Um, people won't they, people won't go off grid. The average, uh, home won't go off grid because it's cost prohibitive. First
Right.
of all,
Yeah. Yeah.
um, you basically have to oversize. You basically have to oversize the panels significantly just to try to reduce, and then it once again it will only be able to use the energy from the panels. Um, it'll probably only use 50 to 75% of the available energy because you want to oversize it so
Right.
that you have a surplus whenever it's sunny. Um, so yeah, it's not practical for that's not something that's practical for the average. However, if you have a cabin somewhere that
Yeah.
has gas heating, basically has gas heating, like gas stove, gas dryer, basically where most of the high energy appliances are or loads are propane or something like that, then it becomes much more doable and
Mm.
not nearly as costly. So
Right. Right.
in cases, to your point, in cases where that starts to make sense, is let's say you're wanting to build a cabin or a getaway or something, which are usually in the middle of nowhere,
Yeah.
which means there's no utility lines nearby. And to actually
Right.
get electricity there, it might cost 50,000, 100,000.
Yeah.
I've seen a few estimates north of 200,000
Yeah.
just to
Sure.
get power there.
Yeah.
So, so in
Yeah.
those cases, you can build a hell of a system for a hell of a off-grid system for 200,000. So
Yeah. And, you know, for our Canadian viewers, that is something that they do, quite frankly, Ira. It's very common for Canadian families to have a second home, what they'll call a cabin or a
Yep.
cottage,
Yep.
obviously, usually in remote areas. And I do see a lot of this where people are technically off the grid because of
Right.
what you just described. It's just
Right.
prohibitive to get
Yep.
conventional utilities where they are.
Yep.
But yeah, but generally off the grid is just not practical for sure.
No.
Let me go back to something, Ira, again, that is unique to how my business has synergy with yours. And what I mean by that is HVAC now is driven by the inverter compressor.
Yep.
You know, the mini splits came onto the market 15 years ago, touting the benefits of inverter compressors. And now we have unitary systems, ducted systems, doing the same, utilizing the advantages of the inverter system. So this is where I'm going with this. You know, in my business, the inverter is taking an AC charge and inverting it into a DC charge to run the inverter compressor, because the inverter compressor is a modulating compressor. And that's how we modulate it. We could have modulated it with an AC charge, but quite frankly, it would have required something like a frequency drive. And
Yep.
quite,
Yep.
you know better than anybody, the cost of that would have taken it out of the residential market. So all inverter compressor manufacturers use you can argue, and I know you could argue, that it's really a simulated DC voltage, but nonetheless, whether simulated or not, it's how we modulate it. It's easier and more cost effective to modulate with a DC charge. So here's where I'm going with this. Your system takes a DC charge and changes it to an AC, just
Correct.
the opposite of what we're doing. So my question to you is this, and a general concern in our industry as it communicates, so to speak, with yours is, do we have a bucking of inverters? And
No.
what problems, if any, does that cause for HVAC systems that are now being run on, like what we have here, a solar system, please?
So most of them, so most inverters, as well as most mini splits, most appliances, um, need to have a clean enough power draw. Like basically, if it's whether it's rectifying the power or whatever it's doing, basically it needs to be smooth enough that it's not causing significant disturbance. Um, but basically, when it can become a problem eventually, but it's usually when it's a facility that has a whole bunch of motor drives, or that where they have nothing in place to try to smooth things out, or what also happens is with maybe some of the fluorescent or LED drivers that are not following some of the or not meeting some of the regulations as far as um, how they're drawing power. So basically, what happens is instead of drawing the energy um, in a smooth fashion throughout the sine wave, basically they're only taking energy at the top and the bottom of it. So they're basically chopping off some of the hill.
Right.
um, and if there's enough devices, what do they call them? Nonlinear loads. So if there's enough of those, or there's devices that are a few milliseconds, for a few milliseconds they're drawing energy, so that it's like a really fast, it'd actually be faster than that. So it's a really fast on and off. And if there's no filter or anything in there that's trying to smooth that out, then theoretically, once it gets bad enough, it could cause enough distortion that would cause the solar inverter to basically disconnect. It would actually disconnect because it's causing enough distortion to where it can't recognize it anymore.
Right.
The only time that I have seen that happen was with an inverter system that it was with a different inverter brand, and it was one that's known to have some of those issues. Like it's really sensitive.
Right.
It was basically there was something in, and it was a commercial. It was an agricultural facility
Okay.
that must have had like a lot of lighting or something in it. I don't know. It was a facility that we couldn't go into the buildings without basically being in a clean suit. So I'm
Right.
not entirely sure what was, you know, what electrical loads were in the facility. We could only measure it outside at the electrical service.
Right.
But basically, there was enough distortion, there were enough harmonics on that service that was during certain times it was causing the solar inverters to disconnect, and basically they would disconnect and then things would smooth out and they would try to reconnect. It basically repeated that cycle, but it would
Yeah.
only do it during certain power levels. And what I found out during some of the testing is because it's still connected to the utility grid, it, um, the energy still, whether the building's using it or whether it's sending energy back, the energy, and I'm going really far off into the technical side of things
Sure.
on the,
Sure.
um,
Yeah.
so basically the energy still goes through the power transformer that the utility company has, right? So if all of the energy is coming through the power transformer into the facility, the power transformer actually has a smoothing effect of the distorted. So the energy after it goes through, the energy that's seen by the utility company on the primary side is actually smoother than what it would be on the secondary side, because the transformer is having a smoothing effect.
Right.
The problem starts when you introduce additional power sources like solar inverters, because if, let's say, all of the energy that the building is using is being supplied in real time by the solar inverters, then the energy no longer is going through the utility's power transformer, because it's going from the solar inverter to the facility,
Yeah.
and the impedance of a solar inverter is significantly, it has less of an effect, almost has no effect on, no smoothing effect, basically, like the power transformer was. So
Right.
in
Right.
that specific case, where um, eh, you either have two options, you either have to fix some of the issues in the building,
Yeah.
um, or what we did there, because people, what happens in those cases is like they'll start pointing fingers. Well, it's got to be the utility company's problem, right? No,
Right.
it's not their
Right.
problem. Well, it's got to be loads in the building, and then the building owner is like, well, it was fine before the solar was installed.
Yeah, of course.
So in that specific case, the fix was to add impedance to the solar system by simply adding an isolation transformer between the solar inverters and the rest of the electrical system. And what that does, no matter how bad the rest of the electrical system is in terms of disturbance, the solar inverters don't care, because that transformer has a smoothing effect
Right.
on what the inverters see. So,
Well, you
so no,
again a couple of things in your answer that jumped out at me. Rectifier. Um, so again, when I'm giving a training presentation on it on inverter-based systems, I talk about that our systems have a filter board, a rectifier, to do what you just described, to even out the frequency, to clean up what I describe as dirty power, Ira. Right. So our systems have that built in, and again, going back with my personal experience with you and the system here, I can remember before we went into the installation process, I asked you this. I said,
yeah,
Ira, our entire HVAC system for the two structures here are based upon an inverter compressor. Are we going to have
yeah,
a problem?
Right.
And I remember you mentioning then that actually the solar system prefers an inverter based system because of the soft, what I call soft
Right.
start technology.
Yep.
We don't bang our compressor on full
Exactly.
lamp draw 3600
Yep.
RPM. We ramp it up slowly.
Yep.
And you said at the time that that's an advantage. Do I remember correctly?
Yes,
Yeah.
it's an advantage because there's less. Um, so some of those some of the conventional compressors that have no soft start, no, they're not inverter based.
Right.
It's not unusual um, to see an inrush current of 100 plus amps on some of these.
Yeah.
And as you can imagine, depending on how long that lasts, if that lasts long enough to where it's pulling down the voltage of the entire system for long enough, then it actually could theoretically cause the solar inverters to trip offline, and then they'll trip offline, and then things stabilize and they go back online. So
Right.
with inverter-based systems, that doesn't exist. However, if you ever add battery backup,
Hmm.
um, we don't have to install soft start or anything like that, because the average battery backup inverter system will not start an AC compressor that has a 100 plus inrush amps. Actually, the limit is somewhere around 50. So,
Yeah. Yeah. Wow. Okay. So again, just to kind of wrap it up in a nutshell, the inverter based HVAC equipment is not going to be an issue.
no,
If anything, it would be preferred over
yeah, yeah.
non-inverter based. Beautiful. That's music to my ears. Obviously, keeps the synergy good between the two. So, listen, Ira, again, because I am so familiar with the Canadian market, I do so much business up there in training. Something that I've learned is that some utility companies, electrical utility companies in Canada, are now, believe it or not, charging their solar customers some sort of, I guess they're describing it as a surcharge. I don't want to say tax, but
Yeah,
it could probably be interpreted as a tax
yeah,
for not using grid
yeah,
or for having solar because they, as bizarre as this is to me, they are hanging their hat on, well, it puts the non-solar user as a disadvantage. Well, yeah, that's the point, in my opinion, but
yeah.
nonetheless. My question to you is this: have you seen this happening anywhere in the States? What do you think?
There's It's happening more and more. In
Mm,
short, yes. The I've heard of it that they tried to do that in Florida, in some areas of Florida. I don't know if it ever happened or not,
mm,
but um, it's my understanding that there's also some of that going on in parts of California. And the reason, and I'm sure there's other places.
sure.
Um, so the reason that this happens is because at a low percentage. So if a low percentage of the utility company's customers have solar, it has a trivial effect. It actually
Right.
is a benefit to them
Sure.
um, if a limited percentage have solar,
Right.
because the the energy that's produced locally only has to travel. Like, let's say you have solar, but your neighbor does not. It basically, the surplus that you're sending out only has to travel from your system to your neighbor. It doesn't have to come all the way from the substation or from the power generation
Right.
facility. Um, so at a small percentage, there's actually a benefit. Unfortunately, at some point, it does go the other way. It actually can cause reliability issues. It can, as well as, I mean, most utility companies, their entire billing structure is based on kilowatt hours delivered to the customer, right?
Sure. Sure.
So when you have net metering and you're basically your net delivered in a month is zero or even negative,
Yeah.
you know, then yes, it does affect. Yes, it does affect your revenue stream if a significant number of customers have that. My is it some utility companies, even here, there's a few that what they'll do. So part of that $16 bill is I forget what it's labeled as, but it's basically a connection fee. It's basically a
Right.
fee. It's a fixed fee to be connected to the utility grid.
Sure.
And
Yeah.
I think for your utility company, I think it's something like $10. It's one of the lowest ones in the state, believe it or not.
Okay.
Most of them are somewhere around 15, 16. And then the total bill ends up being like 17 or 18. And then there's a few that are like 30 or $40.
Yeah.
So in those cases, that's the lowest it's going to be. So unfortunately, yeah, it's becoming more common that things like that are happening. It's unfortunate because it's the wrong way to approach it.
Oh, yeah.
It's a you're penalizing them instead. So you're always going to get a better end result if you find a way to incentivize um, corrective behavior. Shouldn't use the word behavior, but
Yeah.
so for example, if if instead of penalizing the solar customers, why don't you just change, say, the net metering structure? And it's not always a popular opinion, but let's say you change the net metering structure from a 1-to-1 to a 70%. So let's say the energy you send back to us is worth 70% of what the energy that you buy from us. But at the same time, when you do that, you remove the cap. You remove the cap of, or you remove some of the restrictions as far as system sizing, right?
Right. Right.
In order to incentivize people that can to put a larger system in than what they really need. So basically, if you oversize it by 30%, the that cost differential ends up being a net benefit to the utility company actually, because
Sure.
it then also incentivizes investors to, as well as utilities, to invest in storage. It actually incentivizes everybody to invest in storage because um, if the utility company has a 30 cent or 30% differential, then that generally will cover any conversion losses and even some of the transmission losses if it has to go quite a distance.
Sure.
At the customer level, it most certainly covers it. So if you put a battery in, the conversion losses round trip are usually somewhere around 90%. So, or I'm sorry, the conversion efficiency, not losses.
Right.
The conversion efficiency is usually somewhere around 90%. Um, but instead, a lot of or some utility companies are taking the approach of penalizing um,
Yeah.
the solar customers instead of finding a way to incentivize the expansion and the integration of it. So,
Yeah. I hate to say this, but I'm going to say it. I see a class action suit coming up.
yeah, generally, when things like that happen, it is only for future systems, right? Um,
Oh,
in
okay. I
in
like that.
nearly all cases, of changes like that, it is only future systems.
Okay.
So as long as your system is installed and commissioned before that change happens, you're good to go.
Okay. So we're kind of grandfathered in.
Yep, yep,
All right. Well, that's encouraging for sure. Um, so look, Ira, prior to what I'll call the heating season, early fall, if you will, probably early September, Patricia and I received an email from the people who handle our what you would call carbon credits. I call them energy credits, but you know what
right,
I'm talking about. We got an email from them saying that, okay, customer, we're going into the winter months now, and you shouldn't be expecting the same production from your solar system that you've been enjoying through the summer months. And they list things like the length of the sunlight throughout the day now
Right.
shortens, the angle of the sun changes, all stuff I completely understand. Um, we spoke a little bit about this earlier, but to this most current billing cycle, we have not experienced any change.
Right.
It's been
Right.
$16 now. You mentioned earlier that you wouldn't be surprised if the next bill that changes,
Yep.
but I guess my question to you is this. I know what they're saying is factual, it all makes sense, but does it have a significant effect, or could it have a significant effect on your bill during the winter months?
After the first half year, no.
Gotcha,
So,
gotcha.
um, so if your system was installed early in the year, if your system were installed early last year,
Right.
then you would not see any increase in the bill because it had the system had the opportunity during the most productive months to store or to bank an excess of
Bank. Yep.
energy, so that that's not an issue.
Yeah, yeah, that's, and again, we kind of touched on that earlier. Again, because we commissioned early August, we only had that half year, if you will, of banking, as you describe it, which I think is a great analogy. So yeah, I understood their position, and I guess it's them just kind of covering or managing what could be customers' uh, non-realistic expectations, for sure. Hey, look, let's talk energy credits, carbon credits for a second, if you will. Um, what are they? Who buys them? The beauty of this thing, we get a small check, and when I say a small check, $80, $90,
Yeah.
I think it's happening quarterly. It's not going to make or break anybody, but what I always say is the utility company never sent me a check, Iris. So
Right.
I'm happy. I'm happy for the $80 or $90, whatever it is.
Yeah.
But can you explain exactly what the carbon credit is, and where's it going, and who's using it, and who's buying it?
So it's basically, it's and I might get some of it wrong. So it's basically some facilities that can't or won't meet emissions requirements. Um, like, let's say they're large industrial facilities or possibly even generating stations that can't or won't meet the emissions requirements. They have an option instead of having to upgrade their equipment. They have the option to instead buy these credits,
Okay,
or buy these certificates to basically meet that requirement.
sure.
So basically, your renewable energy system has the ability to offset some other facility that is emitting an excess of emission of
Yeah, okay.
uh,
No, it makes sense. Yeah. Yeah, very, very, very cool. And there doesn't seem to be any uniformity about them as far as who buys them, or how much you may receive. Like we have a neighbor kind of diagonal to us that have a solar system which predates actually even their ownership. It probably goes back, Ira, maybe as much as 20 years,
mhm.
uh, and they get a very large check.
So
But yeah, go ahead.
the reason that that happens is about 15 years ago, you still had the ability to register a system that was located in Pennsylvania. You had the ability to register it in some other states. And
Ah,
what was happening is that system that you're talking about, I can almost guarantee that that system is registered in DC, of all places.
oh, okay.
Um, and in DC, those credits are worth probably north of $300 per credit,
Wow, wow,
where here they're 30, $40.
right.
So that's most likely what happened there. Unfortunately, I think early 2013, I think around 2013, they put a stop to that.
Yeah,
And then for a while, Pennsylvania actually had that issue where they were allowing other states to register, some other states to register systems in Pennsylvania. So then the Pennsylvania market got flooded, and they became worth much less.
Right.
So
Right. So once again, kind of grandfathered in our neighbors over there. Yeah.
yep,
Yeah.
yep,
Interesting for sure. Um, so Ira, we just had two consecutive snowfalls here in central PA. Nothing too earth shattering. You know, we don't get a
right,
whole lot of snow in central PA, as you know, but the first snow was about 4 to 5 inches. Then we had a week, and then about another inch to 2 inches came. Um, and you know, you and I discussed this. We were having text conversations because I was concerned, you know, should I be doing something? Should I be making some attempt to clear the snow off? And you kind of stopped me on that, and suggested at the very most just use a leaf blower, which was a brilliant idea. But long story short, where I'm going with this was, I didn't do that right away.
right,
So the snow had an opportunity to thaw and then freeze again kind of
right,
quickly, and now it was no longer soft snow on the panels, but it
yeah,
was ice.
yeah,
And clearly, even I understood even before talking to you, I don't want to try and chip away ice
right, right,
on the panels. I'm going to damage the panels for sure. But here's where I'm going with this. So for about 2 weeks, Ira, the panels were anywhere from completely covered to 80 to 70% covered with either an ice film or snow.
yep,
So look, I completely understand. In fact, I want to share this with our audience. You know, you hooked me up with this phone app that
right,
at any time in real time I can actually see what the panels are producing. And when I
right,
looked at it, when I looked at in those conditions, it wasn't producing anything. It didn't
yeah.
surprise me. But here's what I'm. How can that be avoided? How can a snow covering be avoided? Do we have to get it immediately with a leaf blower? Help me here.
That would be the best.
Yeah,
So if you're gonna clear it, if you're gonna clear it, I would recommend doing it within a few hours of you know
yeah.
of it when it stops snowing. Basically, if you have to clear the driveway, um, probably
Do it at the
if you
same
really
time.
want to, you can also clear the panels.
Yeah.
However, if it's a couple snowfalls throughout the winter period, in the winter time, um, clearing it is optional, because there's, I believe, I would have to look at the performance. If you have the production estimate, if you have that sheet that had the production estimates and how it's calculating the production estimates,
Hmm.
there's a line in there or a value in there somewhere for soiling. Um, and in the wintertime, I usually bump that up to, I think January I have set to like 5 or 6%. So basically, that's anticipating some amount of snow cover
Okay.
that will not result in in any production.
Gotcha.
So if it's the occasional snowfall, I would say it's optional. But
Yeah.
you then run the risk of, well, if it snows and then it stays cold, um, it stays really cold for like 2 weeks on end, then it's not going to clear by itself, really. So
Yeah. Yeah.
that's it's completely it's completely up to each. I would say in the off-grid systems, those people generally always clear it.
Oh yeah, sure. Yeah, makes yeah,
um,
of course.
the
There.
grid tie customers, um, there's probably only 10% of them that continue to clear it
Yeah,
after the first few years.
yeah.
So,
Well, I now that we know and we've experienced this, we know what to do.
yeah,
And the leaf blower, when I first asked you about it, I said, "Geez, Iris, there's some sort of contraption. There must be some sort of contraption I can buy that will kind of sweep the snow up." But here's what we observed. So the first snow was about 4 to 5 inches. The second snow about an inch to two. So the first snow all by itself, because it was heavier, slid right off,
yep,
right? And you
yep,
told us that would happen. It would slide right off
yep,
because of the angle.
right,
That happened, but the lighter snow
yep,
didn't do that because it's lighter, right?
right,
It had more of an opportunity to stay put, and that's what thawed and froze again.
yep,
Um, what brought it to my attention, or that there must be something I can do, is our neighbor, another install that you did across the street
right.
here, who almost has the exact same system, two ground mounted arrays, was perfectly clear, and I clearly he had done something. I
Yeah,
don't know
either
what he did, but clearly he had done
yeah,
something.
either that or his are different panels, or theirs are different panels.
Okay,
Um, and theirs would be more susceptible to the type of panel that would be more susceptible to absorbing heat.
ah,
So if it got even a little bit sunny, um, you know, it theirs are if it gets even a little bit sunny, theirs are probably going to clear a little bit faster.
okay, okay,
However, theirs are monofacial panels, so um, they don't perform quite as well
got you.
as the ones that you have. So it's a minor trade off.
Okay, okay. Well, that's a part of the equation as well, for sure. Hey, look, Ira. You know, your time goes fast when we're having fun,
Yeah.
and our time together is almost at an end. But when this goes to air, this episode will air in May,
Okay.
and when you see it, at the end of every episode, I do something that I call Jerry's Pick of the Month, and it's just an opportunity for me to share with our audience something I've discovered in the last 30 days, a book, a film, a documentary, a tool. Oftentimes, it has nothing to do with HVAC. Um, and what I've been doing since we changed the format to Bathica Banter is to offer my guests the same opportunity. So, is there something that you've discovered recently that really was a turn on for you, and you'd like to share with our audience? What do you got for us, Ira?
Huh. Um, Probably it's unfortunately it's probably related to what I do.
Yeah, that's fine.
At least it's the first thing that comes to mind. Um, so there's a newer inverter that it's like a hybrid type of inverter. So you can basically connect solar panels, batteries, even a backup generator, things like that. There's other brands that have been available for a couple years now,
Mm,
but this is a newer one that's um, priced better,
okay.
significantly better, or um, or at least they were, because the other ones are now dropping their prices.
Yeah, sure. Yeah. Right.
um,
Reacting. Yeah.
but so I've been avoiding that because I try to avoid newer products.
I'm,
I try to
I'm
avoid
with
newer
you.
products and,
Sure.
give it some time. And just recently, I commissioned a system with that inverter, and I was pleasantly surprised by the monitoring interface, like the app. Um, it is, I would say, significantly better
Okay.
than even the other more expensive ones. So
What's the name of the manufacturer? Can you give that
it's
to us,
a
Art?
yeah, it's an EG4. So it's from EG4 Electronics, and it's for the 18K inverter that they have. So I was pleasantly surprised. I've been avoiding them because they were too new, but
Sure.
I'm actually impressed at how good the monitoring part of it is. You can actually one of the really probably one of the coolest things, as simple as it is, one of the coolest things on there. Like, let's say you have a solar system with batteries, um, but you're still grid connected, and for whatever reason you have batteries. um, but
Yeah.
the let's say the batteries, let's say it's like 8 a.m. and the batteries are discharged or are at like 20% because they've been supplying power to the house overnight.
Right.
And let's say it's supposed to be really windy and terrible weather that day. There's actually a button on the app to where you can press it and it will use energy from the grid to recharge the batteries quickly, so that
Yeah.
they're charged, because there's a high probability of there being a power outage that day,
Oh,
so that you're
brilliant.
not. So, like, one of the simplest, and for the off grid ones, for if you're using that in off grid, um, on the it doesn't have it on the app, but on the web page for the same monitoring portal, you can actually start, and if you have a generator connected to the system that's set up to work automatically, you can actually start and stop the generator from your computer.
Wow, brilliant. Yeah, that does sound like quite the
But
upgrade for sure.
it's
And did I hear you? It's EG4
correct.
electronics?
Yeah.
Okay. Yeah, because I'm gonna wanna take a look at that. That's just plain interesting. Yeah,
Yeah.
very, very
I mean,
good.
it may not be something that the average, um,
Sure.
you know, average person is going to use, but if you're, if you're building if it's somebody that's a do it yourself or whatever, and they're trying to get power to an off grid cabin or whatever,
Yeah.
um, I actually feel comfortable using them now. So, uh,
Very good. Well, that's quite the endorsement, Ira, for sure, coming from you. So, yeah, good for them and good for the industry for sure. Hey, Ira, look, thank you so much, my friend.
certainly.
I've been so looking forward to this conversation with you because you're so smart, and you know your industry so well, and you can
Thanks.
articulate it to someone like me who doesn't know your industry very well. So I knew you would knock it out of the park, and you exceeded my expectations, Iris. So thank you so much for spending some time with us. I love you, my friend, and thank you so much.
Yep. Thanks.
So, just a quick correction on my part. When I stated what I thought were the terms of the Canadian Greener Home Grant for solar installations, I was dyslexic. I had my numbers reversed. It's up to $40,000 for a 10-year loan. I had that reversed in my comments, so I apologize for that. So, again, up to 40K, 10-year is the length of the loan. What a great conversation with Ira Zook of Zook Electrical Services LLC. Patricia and I are just so fortunate that we found Ira, and we found him through word of mouth just in the neighborhood. He had been doing our neighbor across the street, doing their system. When we spoke to Don, our neighbor, he had nothing but wonderful things to say about Ira. And yeah, we feel the same way at this point. We could not recommend him higher. Just a wonderful man. You see how smart he is, just incredibly smart. I love when somebody knows their industry and knows their trade. As well as Ira does. Just so impressive to have people like that available to us. So, if you're going down the avenue, considering thinking of photovoltaic solar, watch this episode, tell your friends about this episode, and contact Ira. He's your guy. Okay, so it's that time of the show for Jerry's Pick of the Month. And my pick of the month this month is going to be a documentary. Patricia and I love documentaries, and we found this one on PBS, which is always a great source. And it's in their American Experience series. And the name of the doc is Poison Ground: The Tragedy at Love Canal. Love Canal took place in 1979, 1980. And in 1979, I was graduating from high school, and my life was upside down, all self inflicted. And I was not paying much attention to anything happening outside my bubble because my bubble was all consumed at that time. Uh, so I knew what Love Canal was. I knew the circumstances and the issue, but frankly, I didn't even know where it was. I was blown away to find out through the doc that it's Niagara Falls, New York. Wow. I mean, I'm passing through that on a weekly basis. As you guys know, I do so much work up in Canada. I had no idea that I was literally passing through this area virtually every other week. So that, if nothing else, was enlightening. But just a story of incredible determination, and determination on the part of the women of Love Canal, because the men, again, think of that time in history, that time in our society. Men were out trying to pay the bills, getting the money. And again, I'm not saying that women were not doing that at that time, but this was a typical mid-income community, Love Canal. And many of the women were home with the children, right? Raising children. And it was them that were left to fight this battle with the EPA, with Hugh Carey, the governor of New York at the time, with Jimmy Carter, the president of the United States at the time, the Department of Health in the state of New York. And a battle it was. And these women were relentless. They would not give up. And they got what they needed. They got what they deserved in the end, but not without years of battling and hard work. So just an incredible documentary, an incredible story. We need to be reminded of this, people, because this crap can still happen today, right? This happened in 1979. It didn't happen in 1920. It didn't happen in 1930. It didn't happen during the Industrial Revolution. It happened long after it. We should have known better. These companies did know better. This was proven and has been proven. But nonetheless, it happened, and it could still happen today. So watch the doc. Super interesting. Again, The American Experience is the series on PBS. Poison Ground: The Tragedy of Love Canal. Well, listen, everybody. Great episode this month. Thank you so much again to Ira Zook. Looking forward to next month, where our guest will be Andre Calais, former CEO of Hydro-Quebec. Going to be a super interesting episode next month. So don't forget to hit the subscribe button so that you don't miss any of the future episodes. Thanks so much, everybody. See you next month.